Chapter 8, Rotation of Rigid Body. So in this topic, we have 4 subtopics, 8.1 until 8.4. For the first video, we are going to look at 8.1, Rotational Kinematics. Okay, a bit of revision. Last time in Chapter 2, you have learned about kinematics of linear motion. So from 2.1, linear motion, you have learned the concept of instantaneous velocity, average velocity, instantaneous acceleration, and average acceleration. So for chapter 8, because we are talking about an object moving in rotation, so you need to know the definition and use angular displacement, average angular velocity, instantaneous angular velocity, and also for the acceleration. So there is another word, angular, meaning that we are talking about motion moving in circle or rotation. And then the learning objective B, relate and use parameters in rotational motion with their corresponding quantities in linear motion. Okay, so you have seen S equals to R theta, V equals to R omega, and there are a few more, which is tangential acceleration, angular acceleration, and then centripetal acceleration. The last learning objective is to solve problem related to rotational motion with constant angular acceleration. So we have omega equals to omega naught plus alpha t, theta equals to omega naught t plus half alpha t squared, and then omega squared equals to omega naught squared plus 2 alpha theta. So this is actually quite similar to the linear motion where we have v equals to u plus at, s equals to ut plus half at squared, v squared equals to u squared plus 2as. Okay, so what is rotational motion? It is a motion about a fixed axis. Example, you can see in the image. Okay, a motion of wheels, tops, planets, the rotors of jet engines, and the blades of helicopter. So every object in this diagram, they are rotating about an axis. So ini adalah axis dia. Ini adalah axis of rotation. The same goes for this one. Okay, for rotational of rigid body, there must be an axis of rotation. As the rigid body rotates, all points on the body move in circular path. So you can see all points. For example, we take the point A. So point A has its own radius. Okay, B and C also has its own radius. Okay, so the symbol for angular displacement, theta, the unit is radian. Average angular velocity, omega average, radian per second. Instantaneous angular velocity, omega, radian per second. Average angular acceleration, alpha average, radian per second squared. Instantaneous angular acceleration, alpha instantaneous, radian per second squared. And then let's look at the formula. Okay, so we know that S equals to R theta. Therefore, you can find theta equals to S over R. Or you can just take the final theta minus the initial theta. Okay, and then for average angular velocity, the same as when we calculate the velocity, average velocity is equals to S2 minus S1 over T2 minus T1. So for angular, it's the same. Theta 2 minus theta 1 over T2 minus T1. Okay, and then instantaneous angular velocity, this one actually involves differentiation. If you are given an equation, then you need to differentiate. Okay, we want to find the angular velocity at a specific time at a specific point. And then average angular acceleration. So average omega 2 minus omega 1 over T2 minus T1. Okay, so when we talk about average, perkataan average, kita akan ambil total perbezaan bagi dengan total masa yang diambil lah. Sama juga dengan angular velocity tadi, total displacement yang diambil bahagi dengan total time. Okay, and then angular instantaneous acceleration, this one you need to differentiate. Okay. Okay, next we want to see the relationship between the linear and rotational motion. Okay, so for distance, we know that we have displacement for linear, and then for rotation we have angular displacement. So this is the formula, S equals to R theta. So remember the theta is in unit radian and r in meter. Okay, and then for tangential speed, okay, Vt, for rotation we have angular speed. So V equals to R omega. Remember, omega is in radian per second. Tangential acceleration. So this one is something new for you. So A tangential is equal to R alpha. Alpha is the angular acceleration. So you can see the pattern. It's just that we have R in the middle. Okay. And then for centripetal acceleration, okay, you have seen this in chapter 6, V squared over R equals to R omega squared. Okay. And then the total linear acceleration. So this is actually the resultant acceleration in which, okay, so if you look at the diagram, the tangential acceleration is the tangent of the circular motion, and then AC is the centripetal force going inwards, going towards the center. So the resultant acceleration is the resultant between the two. So what you need to do is find the magnitude by doing the square root of AT squared plus AC squared. Then let's look at rotational motion with uniform angular acceleration. Okay, so for the linear motion, last time you have seen V equals to U plus AT, S equals to UT plus half AT squared, V squared equals to U squared plus 2S. Okay, so for the rotational motion, you just change it to the angular parameters. So tangential acceleration A is equal to alpha, and then V you change it to omega. U initial velocity become omega naught. Omega naught is to show the initial value. So you just change everything to the angular parameters. Remember the unit for alpha is radian per second squared, omega radian per second, theta is in radian. Okay, let's look at a few examples. Okay, number one, a wheel rotates with a constant angular acceleration of 3.5 radian per second squared. So this is the alpha. If the angular speed of the wheel is 2 radian per second at t equals to 0. So given here, at the starting of the motion, t equals to 0, the omega naught is 2 radian per second. Okay, so this is the initial angular velocity. Through what angular displacement? So what is the theta? Does the wheel rotates in 2 seconds? So this is the time. Okay, from there we need to find theta. We already have the value of omega naught and also t and also alpha, so we can use this formula to find the angular displacement. And then B, what is the angular speed of the wheel at t equals to 2 seconds? So this is the final angular speed. So we can find using omega equals to omega naught plus alpha t. So the calculation is very similar to linear motion. It's very simple. Just change the parameters in linear motion to angular parameters. Okay, let's look at number 2. The angular velocity of a wheel increases from 300 rpm to 1800 rpm in 5 seconds at constant rate. Calculate the initial angular velocity. Okay, so in this topic, usually you will be given the angular velocity in rpm. So rpm is actually referring to revolution per minute. So if you want to do the calculation, you have to change it to radian per second. Okay, so the question is to find the initial angular velocity. So this is the omega naught. You have to change it. So 300 rpm. Okay, so we want to cancel the one revolution. One revolution is equals to 2 pi radian. And then we want to cancel the minute. 1 minute is 60 seconds. So from there, ref, min and min. So we have radian per second equals to 10 pi radian per second. Then the final angular velocity, you will need to do the same thing and you will get 60 pi radian per second. Now, find the angular acceleration. Okay, so we have omega naught, we have t. You need to find the alpha. So we can use this formula over here. So the answer is 10 pi and the unit is radian per second squared. Okay, next, during the period, how many revolutions were made by the wheel? Berapa rotation dibuat oleh wheel tersebut? Okay, so we know that for one revolution is equals to 2 pi radian. So you need to find how many radian have the wheel covered and then change it to revolution. So basically we need to find the theta. Okay, so to do that we can use this formula, omega squared equals to omega naught squared plus 2a theta. Then you will get theta is equals to 175 pi radian. Okay, then change that to revolution. Okay, so revolution, you want to find x equals to 175 pi. So x is equals to 175 pi divided by 2 pi. So this is radian times 1 revolution. So you will get 87.5 rev. So this is the answer.